Thank you very much for joining in this poster session. My name is Ananga Thapaliya and I am a bachelor fourth year student studying at Innopolis University in Russia. The topic of the poster and my research is effect on brain activity while programming with or without music. Before starting the poster presentation, let's first focus on two keywords. The first one is EEG, that is electroencephalography device, which is used to measure electromagnetic waves from software developers. And the second one is electromagnetic waves, which are basically bands that are theta wave, alpha wave, beta wave, and gamma wave. So as a software developer, I experimented to determine how programming with or without music would influence the operation of problem solving and programming. The purpose of this study is to gain additional understanding of whether the EEG device can provide successful means of understanding how programming with or without music can impact the work of software developers, basically by conducting a preliminary observational assessment of their brainwaves. As for the research methods, firstly, a systematic literature review was conducted utilizing database search and snowballing strategies to assess research and gain evidence for brainwave analysis using alternative techniques and devices. So these devices can include heart rate variability sensors or fMRI devices and many more. So the first analysis was performed using the software from EEG Studio, firstly to remove the noise from the signal, amplitude and notch filtering were used. After that, the same software was used to clean up the artifacts such as blinking. The band values obtained from the same subjects while they were programming with and without music were compared. For the experiment that I did, electrodes were based on 1020 international scheme, as we can see here on figure 1, where CZ is the reference electrode. And the secondary analysis was done by estimating the coefficient of valence and arousal using Thayer's emotional plane, which is one of the most known models. Thayer published in 1989, as we can see here in figure 2. Thayer's model is based on two basic and effective parameters, music energy and music pleasure. These parameters are known as arousal and valence. So I divided Thayer's model into discrete emotion sections based on the level of arousal and valence. Emotion recognition is conducted on both dimensions of arousal and valence, and the detected music emotion belongs to one of these emotion sections. So basically, arousal is the degree of autonomous activation produced by an incident and varies between calm and excited state, whereas valence is the degree of happiness produced by an incident and is characterized from negative to positive along a scale. To measure the arousal valence values, EEG signals from the frontal electrodes were used. Alpha bands are the most dominant band during a calm state, whereas beta bands are connected to the state of mind that are alert or excited. So I can consider the beta alpha energy ratio as an indicator of arousal. And as for the valence, the literature study I did, where I found that the left hemisphere is less involved in negative emotions and more in memory and positive effects. Therefore, this analysis used the energy difference of the frontal electrodes, F3 and F4, given by the equation that I used to calculate the valence, which you can find on the paper. So for the result, I found a substantial difference in brain activity across the subjects that I have analyzed. The power range was different in programming with and without music. However, a specific brain activity pattern could not be identified in my dataset, nor I could distinguish groups of developers with identical patterns. However, if we look here in the table 1 represents the values of arousal and valence for the control and treatment groups as computed from the recorded EEG signals. So people who listen to the music appear to have lower arousal and higher valence in the treatment group, and as opposed to the control group. So the difference appears higher for valence. However, the limited size of my sample does not allow me to perform any inferential statistics, but just to provide an observational conclusion that music may have positive influence on the programmers. So from these results, I can say that I have a significant contribution from the data I have collected, because I can determine that music appears to have a positive impact on the programmers by increasing both valence and arousal, even if the specific mental effects appear still unclear. So still, this result could be used already now, both for industry to take music into consideration when developing the working environment for their software developers and engineers. And from the academic point of view, the new researchers can use these research as a reference hypothesis for their work. So this is where I conclude. Here is the QR code for my paper, where you can read the paper and find out the references. Thank you very much for joining in. I really hope you liked the topic and had a good time. Thank you very much.